Hey everyone, welcome to our Food Safety Office Hours. I'm your moderator, Sam Alcan, Associate Professor here in the Department of Food Science. Here in Ithaca, the sun is out, snow is gone, it's in the 50s. It's almost as if spring is reoccurring. Buds might be emerging, and life has persisted through an otherwise desolate winter. I know, it's a little dramatic. But it could be worse, right? We could be talking about pathogens in our food processing environments. Right, we are, right? So today we're going to have Dr. Martin Wiedmann sunnily walk us through the importance of understanding whether strains within our facilities are reoccurring, emerging, or persistent, and the implications for control strategies. And then we'll have a panel of experts spring on to provide their perspectives and answers to your questions. We've got a great panel of experts. I already mentioned Dr. Martin Wiedmann, the Gellert Family Professor in Food Safety and the co-director of the New York State Integrated Food Safety Center of Excellence. We've got Dr. Madhu Anand, the Deputy Director of Regional Epidemiology and Investigations Programs for the New York State Department of Health, and also a co-director of the New York State Integrated Food Safety Center of Excellence. We've got Dr. Renato Orsi, a Senior Research Associate here in the Department of Food Science and our resident genomics guru. And we have Melanie Newman, JD, founder of Newman Advisory Services with years of experience in food safety law, risk assessment, and regulations, and an entrepreneur in residence here at Cornell. So start thinking about your questions. If you have them as they pop up, you can enter them into the chat box. And at the end of Martin's talk, we'll start asking those questions to the panelists. So with that, hand it over to Martin.
Great, thanks, Sam. So I'm going to be here to talk about rep strains. And it's, for some of you, it might be a new term. And CDC has thrown it out over the last couple of years. And these are called reoccurring, emerging, and persistent strains. And one of the questions really is, what are the implications of this new set of strains, this definition for the food industry as we try to assure food safety and minimize our regulatory and enterprise risks? I want to start off with an acknowledgement. A lot of the slides were derived from Matt Wise at CDC, who's doing a lot of work and is really, I consider him sort of the CDC leads on these rep strains. So reoccurrence of strains or subtypes of foodborne pathogens is nothing new. And we've dealt with this for about 20 years, if not longer. Here are a couple of key examples. Some of you might remember reoccurrent multi-strain outbreaks of Salmonella Newport associated with tomatoes. There was a while where every summer there was an outbreak of Salmonella Newport linked to tomatoes harvested in the Delmarva Peninsula. That was an every summer incidence. Then we had Salmonella agona in cereal products. Those were 2 outbreaks that were about 10 years apart, but that same strain persisted, or here they call it reoccurrent, and we're going to get a difference between those in a few slides, in a processing facility and caused these 2 outbreaks. Here's another one, slightly different story. So this is multi-drug resistant Salmonella Heidelberg that caused more than 600 illnesses over a 17 months period. There were different PFGE patterns, but they were linked to a number of different slaughter processing establishments in California. And here you can see this was multi-drug resistant, which caused some particular concerns. And this outbreak, if you want to call it an outbreak, or this reoccurrence, really occurred over quite a while. When we started using whole genome sequencing for subtyping of Listeria monocytogenes, something that we knew before then became even more obvious, that we have these listeriosis outbreaks that go over 3 years to 5 years or longer. One of the sort of poster children of that is the listeriosis outbreak linked to Bluebell ice cream. 10 cases over 5 years. We can debate the details of that because these 10 cases actually represent multiple subtypes that are independent, but clearly persistence of at least one strain in at least one facility. Soft cheese outbreak by Caroon Dairies, listeriosis outbreak linked to frozen vegetables that went over quite a while, and of course the current Listeria outbreak linked to a facility in California that is sort of the latest example of these sort of reoccurrent strains. Another examples from USDA regulated foods, Salmonella infantis infections linked to chicken products, 129 illnesses over a 13 months period. These Salmonella infantis are multi-drug resistant. And this is really an interesting one because it goes way above and beyond this outbreak here that CDC reported. In many parts of the world, this general strain of Salmonella infantis has become the most predominant strain found in raw poultry products. I have a colleague in Chile that says when they go to a retail store, collect raw chicken, it's almost always multidrug-resistant Salmonella infantis that will fall into that general group. So this is a strain that really emerged. It appears worldwide and causes problems in many, many different countries, specifically in chicken. Wasn't just chicken. Turkeys had their equivalent, Salmonella Redding infections that occurred over many years, still around. This outbreak strain was isolated from people, turkey meat, pet food made with turkey, as well as live turkeys, also multi-drug resistant. So you can see the theme. Some of these strains, particularly in Salmonella, often are multi-drug resistant. And here's what's going to be the outbreak or the issue that really started the concern about rep strains. So 2016, 2017, so over 2 years, but 10 months period within those 2 years, there's a relatively modest amount as it goes for Salmonella outbreak, 106 illnesses linked to ground beef. The outbreak strain was found in a different source. It was found in 4 dairy cattle from one state, ground beef, but a number of different slaughter and processing facilities, and it wasn't clear where the strain came from. And I remember the discussions at the time that was like, well, maybe this is just a common Salmonella Newport strain that's in certain areas. If I remember correctly, there was even discussions where there was potentially in cattle, both in Mexico and across the border in the US. It wasn't just a single country, etc. And the number of cases, as you can see here on the bottom right, sort of started to trail off. We had fewer cases in 2017. But then in 2018, that same strain came back and caused 403 illnesses, again found in ground beef, traceback. And this traceback pointed to one processing establishment. I'm not here to criticize or confirm that these tracebacks or the recalls were appropriate or not, but it led to a recall of 12 million pounds of ground beef. But the big part here is this strain was there 10 months, and then, year and a half later, we had a much larger outbreak, which, of course, not surprising that some people say, did we do enough in 2016, 2017? Could we have done something different? Could the industry have done something different to prevent this larger outbreak from happening subsequently to this first outbreak? And that leads to this new paradigm that was sort of became the rep strains that we will talk about today. Up to this Newport outbreak, most of these events of what we described were acute outbreaks. Yes, we had the multi-meal cases. We had some other cases where the same strain showed up, in a facility and in the same facility 8-10 years later. But that was different. In this case, we started to see it in more strains, and we started to see it in a different setting where the persistence most likely did not occur in a facility, but somewhere along the supply chain, potentially in the raw material, maybe even the environment of some of these farms. And the idea was that this 2018 outbreak may have been preventable, or at least the scope of it could have been lower if this issue had been addressed. And at this point, CDC decided that, these sort of situations of persistence, reoccurrence, were not unique anymore. They happened often enough that they felt it was time for a new approach. And that's where the Christian or Carl started to develop these rep strains. So what are the rep strains? So it stands for reoccurring, emerging, and persisting. And this shows the epidemiological curve, so the number of human disease cases over multiple years or over time for these different types. Now, these are idealized scenarios, and some of them were real cases, or they were probably real cases, but there's obviously mixture. We can't always separate that easily. So the first one is reoccurring, and that would be a strain in this case, an outbreak that happens every summer or every fall and repeats every year. So classical case will be Salmonella Newport in tomatoes from the Delmarva Peninsula. An emerging strain, probably more similar to a Salmonella infantis or some other strains, you have low numbers. And over time, the total number of human cases caused by this strain become higher and higher. A persisting strain has a more erratic pattern than a reoccurring strain. So you have a case, a few cases, then maybe no cases for a while, a number of cases, no cases for a while, and it shows more erratic patterns than the reoccurring strain, which typically often might be linked to seasons, such as seasons of harvest, et cetera, et cetera. So not all of these rep strains are going to neatly fall into those three patterns. They might represent combinations of them. And some strains might, move from persisting to emerging strain, for example. So different patterns found. But one of the key parts, and which I think is very important, in many cases, we're not talking about our classical specific subtype of a pathogen, Listeria or Salmonella, that persists in a processing facility. Often these stay around, stick around, and cause problems over longer times, and we don't know what exactly the source is in many of these cases. And this illustrates the dynamic nature of these rep strains. So this is Salmonella Redding associated with turkey products. And what you can see here is we sort of had it emerging. It started to become more frequent. Then there was an increase, maybe one facility, and the idea could be that one facility may not have had all the appropriate interventions in place to deal with this. And then it started to persist afterwards. So don't necessarily worry about putting strains into one of these three buckets, but focus on the overall concept. So what's the importance of the rep strains? And a lot of these slides I'm showing here at the beginning are CDC slides. So that gives you a little bit of the reading of CDC on this. So this repeat ongoing identification of the same strain suggested as what they call an upstream contributor. So it could be a field, it could be a general area. In some cases, such as poultry, it could be the farms that have the parent flocks or rear the chicks that go into a lot of different hatcheries. The traditional outbreak control measures, like a recall, don't necessarily address the underlying contributors. They might cause a reduction in cases for a time, but this issue is going to continue with that specific strain. And the paradigm shift is then that we need to address these underlying contributors and overall decrease the risk associated with these strains, reduce their introduction into the food chain so that we don't get large outbreaks or continued increase in the number of cases caused by some of these specific rep strains. And as an emerging area, we're moving into an area where CDC and the states are probably going to use additional and different investigational approaches for these rep strains. They're not just going to try to trace it back to a single facility, but they're going to try to trace it back further upstream of the facility to identify that field, that watershed, or that hatchery or upstream source that contributes to sort of continued introduction of this rep strain into the food supply chain. This is not a CDC alone sort of approach. CDC, there's something called the Interagency Foodborne Outbreak Response Collaboration that includes CDC, USDA, and others that are involved, and FDA that are involved in this. USDA APHIS, so those are the people that go on the farms are involved in it. Because a number of these strains are antimicrobial resistance, the NARM system is involved in it. Renato and I and Madhu recently were at an Inform meeting where it was quite a bit of conversation about these rep strains and how we address them. And part of it also moves towards CDC's interest in prevention rather than just outbreak detection. So here's a table that indicates some of these potential rep strains. You can see rep strains get assigned rep codes. And I'm not going to walk through all of them, but I'm going to give you some ideas. Some of them we mentioned. For example, Newport foodborne cucumber tomatoes here. That's what I would call the rep strain linked to the Delmarva Peninsula. We talked about Hadar in poultry. We talked about Salmonella infantis in chickens. We will talk a little bit more about some of these 0157H7 strains that are specifically found in Yuma or the Salinas area and have been responsible for a number of outbreaks linked to leafy greens, but also outbreaks linked to water or even ground beef. Simply speaking, if you have one of these strains in a general environment, such as in an irrigation system, that water can be used to irrigate produce, but it could also be drinking water for animals, or it could be used to irrigate forage that ultimately is fed to animals. So that same strain can infect cows, can contaminate ground beef produced from those cows, and can contaminate leafy greens. And finally, and this was one that was announced in a presentation at the Institute of an IFP meeting last year, a rep strain of Listeria monocytogenes, more than 70 isolates. And there's sort of a what I'm going to call a vague history of linkage of people infected with this Listeria monocytogenes to consumption of potatoes and frozen potatoes, as well as findings of this strain in potatoes. The interesting story there is that apparently Mexico tests raw potatoes that are exported from the US into Mexico. If they find Listeria monocytogenes, they perform whole genome sequencing, and these data get added back to the NCBI, so this whole genome sequence database. And if you look at that database, you can see there are potato isolates and then there are human isolates, and apparently at least enough of these human cases have a history of consuming potatoes and frozen potatoes. And I'm going to pick on that a little bit because I think it's an interesting case study in terms of now that it's known that this strain is out there and linked to frozen potatoes, what are the responsibilities for some of the industry and companies working in this space? The other important thing, this once again illustrates how rep strains are different from your classical outbreaks. There wasn't one recall, there wasn't one facility implicated. It appears to be across the industry and across different facilities, potentially. It might also not be potatoes. It's not the final word. And that's the other thing which we need to keep in mind with some of these rep strains. So there's a strong interest in CDC as well as FDA side. I've not seen that much from USDA, but that's probably coming to learn more about these rep strains, to understand why they are rep strain. Are they more resistant to sanitizer or interventions? I've not seen any evidence for that, but those are the questions that are being asked. And then to also move into collaborative studies to better understand where these strains are found, why they persist, and importantly, what could be done to reduce, control these strains. CDC will communicate about these rep strains, and there actually is a web page for rep strains already up, and that's, I think, is an important one. If I were in the food industry and responsible for food safety, I would monitor that web page. And so here's the web page. So we're going to move into some slides that so up to now was really largely slides from Matt Weiss. So this is, reflects sort of CDC thinking with a lot of interpretation by myself. So here's the web page. If you want to go to that, fairly easy to find. I think if you probably just Google rep strain CDC, you will find that. Within that web page, there are now specific pages for different rep strains here. So you can see an E. coli rep strain. You can see the Salmonella Hadar strain that we discussed, the Salmonella infantis strains linked to chicken that we discussed, and the Salmonella Newport strain that was linked to beef, traveled to Mexico, and soft cheese, potentially soft cheese, that came in from Mexico too. So this is that Salmonella Newport rep strain. So those are 4 examples that are on that list right now. You will remember that what I showed you on that table had more strains. Expect some of them to be put up sooner or later. And also expect what we already seen is that it's almost like a soft launch to some of these rep strains, because the potato Listeria rep strain was announced at IFP. There was a 20-minute presentation from a CDC press center on that, but it is not on the CDC webpage yet. So what are the actions that can be taken to prevent illnesses? What are some of the CDC expectations? Again, emphasis that This is not a single food source in many cases. Many of these rep strains, the idea is that they might be transmitted through different modes, foodborne, waterborne, person to person. Often it's not clear where to intervene, but you can start to see some themes, okay? Water treatment, control of the live animal side, vaccination of animals, and that could be chickens, that could be turkeys as an expectation, or it could be what we've heard talk about vaccination of cattle to reduce O157H7 shedding for some of these rep strains that might be linked to some of the environments in California, for example. These are not simple one company interventions. Often the idea is that some larger groups need to come together to address some of these strains. And we'll put some more explanation on that in some of the next slides. Big picture, and I think it's important to keep in mind is, so far, if you look at CDC, FDA, USDA, there's been a lot of focus on outbreaks, but outbreaks is just the tip of the iceberg. There are many, many more sporadic cases. And one of the goals, if we want to reduce foodborne illness cases in general, we need to drive down the incidence of sporadic illnesses. Rep strains blurs that boundary between outbreaks and sporadic strains a little bit. It might be a different part of the sporadic strains, but it also illustrates, and I think it's important for everyone in the food industry to know that sort of increased emphasis on not just outbreaks, but sporadic cases. All right, so now let's move to a specific example, which I think will illustrate something that we could see in other areas. This is produce industry, and it's a FDA report. And this FDA report was on an outbreak that happened in the fall of 2020 of E. coli L157 in leafy greens. And in that 20-some page report, I highlighted took out a few citations. So one of them is, so this is an FDA report, not CDC, and it refers to this reoccurring pathogenic E. coli strains that's been associated with numerous foodborne illness outbreaks. And here's the key language that made me stop when I read this for the first time. And therefore appears to be a reasonably foreseeable hazard in this specific region. And they even put a nice little map saying, hey, essentially the way I interpret it, and I'm going to throw a question about this to Melanie, saying, hey, if you grow produce in this region, you better tell us how you're going to make sure this strain does not come on your product, because we just define it as a reasonably foreseeable hazard. There's a nice little map telling you where it is. The report goes on to be what I find even more detailed. And, it's recommendations. So here, FDA recommends that growers of leafy greens in these areas consider this particular strain a reasonably foreseeable hazard, repeating that language, and then remind people of the produce safety rule, what they need to do. And then FDA expands it to recommendations for all producers of leafy greens, specifically focusing on the risks as potentially associated with adjacent land use, presence of livestock, and the interface between farmland, ranchland, and other agricultural areas. And for those of you not sort of that familiar with Salinas, is essentially many parts of the Salinas Valley. You have a valley, and you have two sides of the valley, and their cows are on the sides of the valley. And the idea, and I'm going to emphasize idea, is that if these cows were contaminated with O157H7, deposited fecal material, and so you got runoff, then there's a risk of that E. coli going into the valley and potentially contaminating produce. So what are the implications of this for food industry? And I'm seeing possible expectations that industry will take specific action to address rep strains. Example I gave you for produce industry, in my mind, pretty clear. The fact that CDC went up at IFP, talked about Listeria monocytogenes in potatoes, pretty clear that the expectation of people in that industry to potentially assess this risk and see how they can minimize potential risks of contamination or human illness. It might be seen as a warning signal for certain industry sectors. I think it definitely is a signal for a future focus on identifying the sources of sporadic illnesses and increasingly smaller outbreak or smaller clusters of cases. And finally, I think this may have some interesting implications for what I call the eternal SNP cutoff debate. What do I mean there? Yeah, if you have foodborne disease outbreaks, the debate often is like, well, if two human isolates differ by a certain number of single nucleotide polymorphisms, a measure of relatedness based on WGS data, at what point are they the same or close enough that we can say they're the same source? Typically, when we talk SNP cutoffs, we're talking about ranges of 10 to 20 SNP differences. Many of these rep strains are defined by a much larger range of SNP differences, often in the range of 50 and more. So it does going to become interesting in terms of how these larger cutoffs might be used to identify specific risks, maybe not linking to a specific company, but link it to specific supply chains as we continue to expand that.